Hello and welcome to section 1.3 of Algebra 1 Part 2. Today we're going to be talking about solving equations with variables on both sides. Some things that we want to do in order to make this as easy as it can be is we want to start off by getting both sides to be their simplest forms. Okay, we want, like, if we can get it to something multiplied or divided by a variable plus something, that would be the best if we can get both sides to look like that. And we'll see what we mean by that as we get into some of these examples. But so we want to kind of use our distributive property and combining like terms as those steps 1 and 2 to get that each side to be as simple as possible. Excuse me. And then what we want to do is we want to move all of our variables on one side and all of our numbers on the other. And then we want to solve. Okay. So we'll go ahead and take a look at that. With this first one, steps 1 and 2 are already done. I already have a variable term and a number term on both sides. Again, when I'm talking about terms, I'm talking about things separated by plus or minus signs. So I have a variable term, a number term, variable term, number term. And so that's really, from up above, that's steps 1 and 2. Okay. Step 3 is then going to be, I want to move one of these variables to the other side. When I move things to the other side, I undo them using addition and subtraction. Okay. So I'm going to move this 3x to the other side by subtracting 3x from both sides. And this is why I chose my words carefully earlier, in earlier lessons, that I want to move things to the other side. And it's really as simple as that. Move that 3x to the other side. You can't just say, I'm going to pick that 3x and move it over there. But in order to move it over there and keep everything balanced, I have to take it away from this side. So I also have to take it away from this side. Okay? 5x minus 3x is going to be 2x. And so now I'm looking at 2x plus 15 is equal to negative 15. Now it's really just a problem from yesterday where I have a two-step equation. But I'm going to keep that same mentality and I'm going to move the 15 to the other side. I'm going to do that by subtracting 15. Negative 15 minus 15 is negative 30. Okay. And then the last thing I'm going to do is use my properties of equality. And at this point, I should have just a one-step equation. And it should be a multiplication or division type of one-step equation. And so I have 2 divided by 2 over there, negative 30 divided by 2 over there, and all that work, and I'm back to a negative 15. Okay. So when we're looking at these, there's easy examples and there's harder examples. Okay. Ones like this one that we just did are more of the easy example type. And that's this first one that we have here. I have variable term, number term, variable term, number term. Okay. I don't have any parentheses. I don't have two number terms on one side. Like this doesn't say negative 14 plus 4 over here. I mean, that's a bad example. Let's say plus 5 over here because I'm going to end up adding 4. You know, it doesn't say this where I have these two terms that I should combine. So in other words, steps 1 and 2 from up above are already done. So I'm going to move my variables to the same side. I really like moving my variables to the left side and my numbers to the right side. Okay. As you get more better and better at this, you can do those at the same time. I can subtract 12x from both sides, and I can add 4 to both sides. So think about what I'm doing there. I'm taking the 12x off of one side, and since I have to, in order to take it away, I have to take it away from the other side. I'm going to put the numbers on that side equal to 0. So the numbers on this side I want to equal 0. So I'm going to add 4 to that negative 4. So I'm going to add 4 to that negative 14. And so what that's going to give me when I do all that at the same time, 2 minus 12 is negative 10x. Those cancel. And negative 14 plus 4 is equal to negative 10. Sorry, I need to think a little bit. And now I just have variable term equals number term. That's what I've done. Divide by negative 10, divide by negative 10, and I get x is equal to positive 1. There we go. This one over here, I'm going to distribute first because I have these parentheses. I'm going to distribute this first. Okay, 2 times x is 2x. 2 times negative 4 is negative 8. And that equals negative 2x minus 10. I'm going to do that same thing. I'm going to move my variables to the left and my numbers to the right. So I'm going to add 2x, add 2x. And if you need to, just do that, right? And there's multiple times that's all I'm going to do. I'm going to do that step, and then I'm going to reassess and see what I have. 2x plus 2x is 4x minus 8 equals those cancel, and I have a negative 10. And now I can add 8 to both sides. Now it's a problem that I saw from yesterday. Two-step equation. I'm going to get 4x. I'm going to cancel those and get negative 2. And now I'll divide by 4. I'm kind of running out of room. I know. Dang it. It's okay. Divide by 4, and negative 2 divided by 4 is probably best seen as negative 1/2. Okay, and that's my answer. So I can get fractions. That's a possibility. That's okay. It's just another thing that can happen. And again, if you're of the mind and you can do what I did up here, kind of do both those things at once, I'm going to move the 8x over, and I'm going to move the 12 over. I'll subtract 8x, subtract 8x, subtract 12, subtract 12. Sometimes I like varying the colors. Sometimes I don't because I know that you can't really do that. If you're just using a pencil, you just have one color that you're using. Sometimes I like to vary it because it helps out visually, but just showing you it can be done with just one color. 3 minus 8 is negative 5. 12 minus 12 cancels. 8x minus 8x cancels. And then negative 8 minus 12 is negative 20. Divide by negative 5. Divide by negative 5. Negative 5 divided by negative 5 is 1. 1x. Negative 20 divided by 5 is 4. There we go. Okay. Let's check our next problem, just kind of assess what we need to do. I see some parentheses. And even on this side, I see variable term and variable term. I can combine those. 80 minus 30 is 50. So I have 50 n's. That's kind of cool. I don't have a number over there. Let's see what I get on the other side. Got negative 10 that I need to distribute. And this is kind of weird. Minus and minus 1. I'm going to think of that as a negative 1. And I'm going to distribute that negative 1 in there also to get rid of all my parentheses. So let's do the first one first. Negative 10 times 2 is negative 20. Negative 10 times negative 5 is plus 50n. And then I have negative 1 times n. And I have negative 1 times negative 1, which is plus 1. Let's simplify this side. So I see that I have number term, variable term, variable term. So let's deal with that. Let's put my variables first, I guess. 50 minus 1 is going to be 49 n's. Negative 20 plus 1 is going to be a negative 19. So this kind of looks like the previous problem, but I don't have a number over here to move. I just have the n's to move. So I'll subtract 49n on both sides. It's kind of a weird two-step equation that we didn't talk about when we had two-step equations because it's got variables on both sides. That's kind of specific to today. So those cancel. 50 minus 49, that's okay. And over there I just have negative 19. What do I do next? Nothing, I'm done. Right? I have n equals a number. That's what I wanted. Now there are some crazy things that can happen once you introduce having variables on both sides. And it's kind of crazy, but if you look really hard, you can see that, yeah, that's going to be kind of weird. Okay? When any number that you can think of is an answer to an equation, is a solution to an equation, then it's called an identity. Okay? These can happen when both sides of the equation equal each other. And we can kind of hide that they equal each other. But once you simplify it, it's easier to see. Then the other side of that is if no number exists that makes it happen, that makes the equation balance, then it would be seen as no solution. These can only be found when all the variables go away and you have two numbers on both sides, two different numbers on both sides. So let's take a look at these two possibilities. So on this one, I have 5 plus 5x equals 5 times x plus 1. At face value, they don't look the same. They don't look the same at all. Sure, I've got some 5s, I've got some x's, but one side has a 1, one side doesn't. But if I simplify this side by distributing, so over here I'll have 5 plus 5x equals 5x plus 5 times 1. That's kind of weird. Remember, in addition, I can switch the order. I could actually say this as 5x plus 5 equals 5x plus 5. Now, right there, you might be thinking, okay, something weird's kind of going on, right? This doesn't look great. Let's say that we don't suspect any foul play. And we say, all right, I'm going to subtract my 5x. I'm going to move this one over, right? I'm going to take this one, move it over. Well, when I do that, I'm subtracting 5x from both sides that already have 5x. So these cancel and these cancel, and I have 5 equals 5. What it comes down to is, sure, even if I still okay, something weird's happening, but I don't have any x's. But this right here is a true statement. 5 is equal to 5. That means the answer is the identity, or we could say a little bit easier, all real numbers work. Okay, I have 2 lines to start that R. That means that all real numbers work. Let's look at this one over here. So this one I would distribute 2n, 2 times n is 2n, 2 times negative 1 is negative 2. I would distribute also over here, 2 times n is 2n, 2 times 3 is plus 6. And this one, yeah, they don't look the same, right? I got a 2 over here, 6 over here. But they both have 2 n's. And when I try to move my 2n over, and even if I said at the same time I'm going to move the negative 2 over, so I'm going to subtract 2n, subtract 2n, and let's say I use that trick of I try adding 2 to both sides also to cancel those, right? I'm going to have 2n minus 2n cancels, negative 2 plus 2 cancels. So over here, everything canceled out and I have 0. Over here, 2n minus 2n cancels, and 6 plus 2 is 8. Well, I can't think of any world where 0 equals 8. That right there is a false statement. That's false, so there's no solution. There's no possible value for n that makes this work. Okay, try these two down below and see. I'm guessing it's going to be one of these two special answers, but pause the video, give it a shot. Okay, hopefully you had a chance to do that. Let's go ahead and take a look at what happens on these. On this first one, I'm going to distribute first. Negative 4 times 1 is negative 4. Negative 4 times 6 is negative 24. Whoa. Whoa. Whoa, 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 whoa. Negative, let's just try that again, 24v. On the other side, I have 9 minus 24v. Now, I don't think much at this point. I don't get too concerned yet because I've been tricked too many times that, okay, well, if one of these was positive, then I just have a lot of v's when I move them to the same side. So I don't get too caught up yet. But I do know, like, okay, there could be something weird that happens here. Let's add 24v and reassess. Does it actually work out that everything cancels? So negative 24 plus 24, those cancel. And I get negative 4 over here. I'm going to have that 9. And negative 24 plus 24, those cancel. Well, negative 4 doesn't equal 9. And, even if I tried to do anything, sure, add 4 to both sides. Like, I could have done that. I could have added 4 to both sides. That cancels, I get 0, and 9 plus 4 is 13. Still, nothing changed. It's a false statement. It's not true. 0 doesn't equal 13. Negative 4 doesn't equal 9. Nothing I can do there. That's going to be no solution. I'll be okay with no SOL. No SOL. Okay. If I look at the other one, right, I've got this negative 8 and positive 7 that I should combine first. Negative 8 plus 7 is negative 1. Kind of looks like something fishy might happen. Let's move my m's over here. I don't know why I wrote that negative 1 there. Give myself a little room, please. That'd be nice. Subtract 4m, subtract 4m. Those cancel, those cancel. Uh-oh. Negative 1 equals negative 1. That is true. Negative 1 does equal negative 1. Feel like a genius when I come up with those. Yeah, it does. Okay, and what that means, and like this said before, you could put any number in here for m. You could put 1,000,000 and both sides would be equal. Whereas on this one over here, it doesn't matter what number you pick for v, it's never going to work out. Okay, this one's a true statement. We get all 2 bars on the r to mean all real numbers. Anything that you pick is going to work. Okay, it's the identity. All right, that being said, make sure you ask any questions that you have, and we will see you in class.